Welcome to this video on homologous structures, part of our evolution series. Homologous structures are fascinating pieces of evidence that help us understand how different species are related through evolution. They show us the remarkable story of how life on Earth has changed and adapted over millions of years, all while retaining traces of shared ancestry. Homologous structures are body parts found in different species that share a similar structure and developmental origin, even though they may serve completely different functions. The key point here is that these structures have the same basic anatomy, the same underlying blueprint, but they've been modified to perform different tasks in different organisms. This similarity in structure despite differences in function is a powerful clue about evolutionary relationships. The most famous example of homologous structures is the forelimbs of vertebrates. Consider the wing of a bat, used for flying through the air, the flipper of a whale, used for swimming through water, the leg of a horse, used for running on land, and the arm of a human, used for grasping and manipulating objects. Despite these dramatically different functions, all four limbs contain the same basic set of bones arranged in the same pattern. This common pattern is called the pentadactyl limb, meaning five-fingered limb. It consists of a single upper bone called the humerus, two forearm bones known as the radius and ulna, a collection of small wrist bones called carpals, and hand or paw bones called metacarpals. This five-digit pattern appears across countless species, from amphibians to reptiles to mammals, showing their shared heritage. So why do these similarities exist? The answer lies in evolution. All of these species inherited the same basic body plan from a common ancestor that lived millions of years ago. Over time, through the process of natural selection, this basic structure was modified and adapted in different ways to suit different environments and lifestyles. Bats evolved wings for flight, whales evolved flippers for aquatic life, and so on. Homologous structures provide compelling evidence for evolution in several ways. First, they show that different species use the same building blocks, inherited from shared ancestry. Second, they demonstrate divergent evolution, where a single ancestral structure becomes adapted for different purposes. Third, they reveal common origins and show us the branching relationships between species. And fourth, they trace evolutionary history back millions of years, giving us a window into the past. Vertebrate limbs aren't the only example of homologous structures. Consider vertebrate skulls, which show similar bone arrangements in fish, reptiles, birds, and mammals. Or plant structures, where thorns, tendrils, and spines are all modified stems serving different purposes. Even mammalian teeth, like incisors, canines, and molars, share similar underlying structures despite their different shapes and functions. The key takeaway is this: homologous structures reveal shared ancestry and demonstrate how evolution works by modifying existing structures for new functions. Rather than creating entirely new body parts from scratch, evolution tinkers with what already exists, reshaping and repurposing inherited structures. It's the same origin, but with different adaptations. This elegant principle helps us understand the unity and diversity of life on Earth.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.